Just like most weeks, they're really not too bad. And there we're going to be doing a little bit of the mean expanded, but really we're going to be here about half an hour, maybe 40 minutes tops. The case study there is due after reading week, and I hope that that's doing all right. I threw scatter plots in there, but they're not bad, and it takes 2 seconds to figure out how to do them. So you guys will be fine on that. I'm assuming you guys are a good class. The marks for your quiz, your assignment, and your test, I'm on it. It's not excuses. We've just had. It's too hot in here. It's just been a crazy time, and but yeah, next week is reading week, so everything will be cleaned up, and the ones there that I've marked, you know what I mean, I haven't seen any issues at all, so yeah, everything looks good, and I hope you guys are doing all right, and yeah, I guess I'll just if you guys have any questions, the three of you, but I know this video is for everybody else. I'll be posting this there to YouTube, but if you guys have any questions, just let me know. Other than that, Ian, shut up and let's get on with things. Yeah? Yeah? Okay. You got it. All right. So, this lecture here isn't bad at all. So let's just get on with it. And we're still dealing there with the measures of central tendency. Okay? Where we're going to focus there today is on the mean. There's what's called an arithmetic mean and a non-arithmetic mean. So it's not too bad. And we're going to touch on something called the mid-range immediately. And are we going to be using this there today? No. Sorry, I guess I need to be sharing my... Am I sharing my screen here? No, I'm not. Okay, so... let's get on with things here. So today we're going to be dealing with the arithmetic mean and the non-arithmetic mean, okay, right here. And we're going to touch on the mid-range there today, just a tad, okay. And are we going to deal with the mid-range there today? No. But it's just my sneaky way of throwing things at you so that you think that you forget them, but in 2 weeks it's still there in the back of your brain, and when we really do need this there in a couple weeks, you guys will be all over it. So, the mid-range, you have just a group of numbers, okay, and you put them in order, and to find the mid-range, like the midpoint. So it's just another way of showing you guys a measure of central tendency. That's all this is. And is it exact? No. But does it kind of work? Well, yeah. So the mid-range, you just take your lowest value and add it to your highest value and divide it by 2. So in this case here, I have 2, 3, 6, 8, 4, 1. You take the 1 and you add it to the 8. You get the 9 divided by 2. You get the 4.5. All right? And that is that. Shouldn't be any question. Yeah, if you have any questions, let me know. But that's what this is. That's the mid-range. 2 seconds in and out. Let's move it. And as promised, like the first test there is dealing with, organizing data in a, taking mashed potatoes and kind of making some sense of it. And, you know what I mean? You guys are doing great on all that stuff. And where we're moving to is we're looking at the data as a whole. And like if you think about the, well, here. Let's look at this one right here. Symmetry and skewness. And you see here we've got, I don't know, we're plotting something here. Let's say it's the number of French fries eaten at one sitting for males over 40. Whoa, crazy. So, and you'll see here that, I'll blow it up a little bit. And if you look at this one right here, there is no skewness. And what I mean by skewness is, you know what I mean, is there, it means that there's a tail to it. It means that there's something going on. And what I mean by this is, you'll see here that this is perfectly symmetrical. Okay? And in this case here, the mean is equal to the median, which is equal to the mode. Okay? And you'll see there that basically the left side is a mirror reflection, kind of the right side. And that's what we really want when we're talking about population statistics. And you'll see here that 50% of the data is on this side, 50% of the data is on that side. One peak, right? And you'll also notice here that whatever your mean, let's say this is 13 French fries is the mean for, a number of French fries eaten for males over 40. All right. And you'll see here that in this particular data, this is the most, which is what the mean is, median, mode, that's what we're talking about here, right? That's your central point. But then if you look at all of this data right in here, this is somewhere in around 70 to 80 to 90% of all the data seems to be circumventing this one point, your mean. And that's what we're looking for. That's what we're talking about, symmetrical. Okay? And where there's one idea, the mean being shown here, and everyone pretty much is in this area. So if 15 French fries is the mean, well, you know what I mean, we've got some people that eat 16 and 17 and 18, and then we've got some people there that eat, I don't know, was it 14, 13, and 12. So everyone is in this range, but you'll see out here, we do have some people that, heaven forbid, they eat 24 French fries at one sitting. And we've got some people here who eat only one, right? We'll get into something called outliers there in the next screen here. But this is what we're talking about. And we're looking at the data as a whole. And this is very important that we have a distribution that looks like this, because it tells us so much. So I'm kind of foreshadowing here because we're going to come back to this. All right. Just some different examples here of distributions. This is the one here that we just saw in the previous slide. It's nicely symmetrical. It's kind of a mirror image where the mean, median, mode are all the same, eh? All right? But then you can get ones that are skewed right or skewed left. Okay? And it's interesting when you have what's called a positively skewed or right skewed there, your mode, median, and mean are kind of set up like this. And it works the opposite way there in a negative skewed or left skewed here. So this is where we're getting into. You know what I mean? The first half of the course is just getting all the basics, getting all of your wheelhouse ready to go. And then the second half there, now we're moving on into bigger and better things regarding the entire population as a whole and looking at it. You know what I mean? So that's where we're at. That's where we're going. We're going to kind of leave that, and we're going to go back to it there after reading week, okay? And this is where we're at there today. We're hitting the mean. Last week we covered these ones here, okay? And now we're going to hit the arithmetic. Maybe I'm saying it wrong. Anyway, let's move on, shall we? It's not an English course. It's a math course. Let's go. The simple arithmetic mean is not always the best way to calculate the average of a set of data. Okay? And all examples below the mean would not provide a true average. And you see, we'll show you these examples, and there's two more there on the other page. And if you look at this, marks from 6 different evaluations. So I have quizzes, assignments, tests, and labs. They're all worth different weight. So how can I add them all up and divide by the number if they're all weighted differently? Like if I got 75% on an exam that's worth 20%, and I got 99% on a lab that's worth 3%, where's the meat going to be? Sure it is, right? And you can't judge a 20% test against a 3% lab. Okay? So, but I'll show you guys how to do that though. This one right here, figure skating scores from 10 judges with an extremely low or extremely high score. So let's say this person there, they got a 9.8, a 9.7, a 9.6, a 9.3, and a 9.9, and then another judge gave them a 6.5. Well, that 6.5, okay, you can add them all up and divide by the number, but that 6.5 is going to drag all those other higher numbers down. So is that a true representation of what we're looking for? We will show you. Okay. The contributions from each evaluation score are not valued equally, therefore an error just wouldn't work. Okay, we've got to modify. Okay, some more examples here.
Sorry, sir.
Yeah, talk to me. What do we got? Who am I speaking to? Riley.
Riley.
All right.
I just had a question. I missed the last 2 classes because it wasn't letting me get into the WebEx. I just wanted to know when the next test is.
The next test will be week 9. So next week is reading week. And then the week we come back is week 7. That's when your case study is due. And then week 8, the following week, is quiz 2. And then the 3rd week back will be your test 2.
Okay.
All right. And Riley, if you can't get in, I don't know, there's something, you email me, okay? And are you getting the lectures on YouTube?
Yeah, I just went in after and I watched them.
Okay, all right. Well, that makes me happy. All right. So if you have any issues with logging in, you let me know ASAP, okay? And okay, very good. Thank you.
Thank you.
All right, it's all good. So we have going back to the figure skater, you know what I mean? You can have extremely low or extremely high scores. Remember, like let's say all the data is around 14 French fries. You know, that's what people are eating. But then you have one person who sits down and has 48 French fries at one time. Outrageous. Way too much carbs. And that's what we call an outlier. Okay? And sometimes they're important to a study. Sometimes they get the snip. So we'll show you guys all this, okay? Some more examples here. If you invest money into the bank, and you see the example here, 5 consecutive annual rates of growth on an investment. So let's say I invested $100 at first year at 10%, and then second year at 15%, and then 17%, and then 18%. How can you measure these? And we'll show you guys this, okay? And there's the last example, which we'll show you, is rates of speed for a triathlete. So you look, that a triathlon is unbelievably unattainable. Maybe I could do a half marathon someday, but the first one there is swimming, and then biking, and then the running. And you see, you're all moving at 3 different speeds, right? So how do you compare swimming to running? You know, if I wanted to find an average rate of speed for this athlete over the course of the triathlon. Well, it makes it difficult, but we'll show you guys how to do this, okay? So in these cases here, we'd be using something called the non-arithmetic mean, but we'll get into this. It's not bad at all. It's not bad at all. So this is what we're going to be talking about here. There's your arithmetic mean. We're going to be talking about a little bit about the simple mean, a trimmed mean, and the weighted mean. Easy peasy. And then we've got the non-arithmetic mean, where we're going to get into some little formulas. But again, they're not bad. I've got a little bit of a math review there for you guys, so rock and roll. An outlier is a number that is very different from the rest of the group. If the data set includes outliers, these will not only affect the mean, but they will strongly affect the mean. Just like going back to the figure skater, if the figure skater has numbers in the high 9s and then one bad judge gives this person 6.5. Well, now that whole average of in the high 9s is going to get pulled down probably into the low 8s. All right? Makes a big difference. Okay? As such, it may be helpful to remove the outliers. Okay? So, if you look at these numbers right here, I got 3, 40, 45, 52, 60, 66, and 70. You can see just right here that there is one number that just doesn't belong here. Where did that come from? Sesame Street. Wow. And you see here, if you do the mean, just a normal mean of these numbers here, you get a number of 48. But then, if we do a snip and we cut this number out, which doesn't seem to belong there anyway, look what? Our mean goes up to 55.8, which tends to, it's in the middle of these guys, and it's right in here, which is where it should be. But that 3 drags the whole thing down so that the average is somewhere in here. You see, out of all the numbers. So, in this case here, you see, what we've done is we're going to do something called the trimmed mean. And how is this going to work? I'm going to give you a question, and I'm simply going to ask you to calculate a 10% trimmed mean. That's it. There's lots of other percentages that we could use for trim means, but I'm only going to go for 10%. Okay, as far as I can see. And what does this mean? We'll show you. There are 4 steps. So you have these numbers here, right? And they all kind of look the same. 8.6, 8.2, 7.8, 8.4, 9.0, 6.8. That one looks a little suspect. 8.2, 8.6, 8.0, 8.6. Ha! Something we could do here. So how do we calculate a 10% trimmed mean? Well, you count up how many you have here. How many data points do I have? So I have 10. All right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Whew. Just wanted to make sure. Okay, so now we're going to determine what this trim mean is. So you want to arrange the data into order. So from lowest to highest. C'est bon? Bon. Okay. Now, identify the number of data points to be removed by multiplying the size of the data set by the percent to be trimmed. So how do I do this? The question asked me to perform a 10% trim mean. Sorry, my mouse double clicks. I need to get a new mouse, and yeah. Therefore, since there are 10 data points, 10% of 10 is 1 data value, right? If there's 10 points, dude, why does it keep doing that? If there's 10 points, 10% of 10 is 1 data point. All right? Now, what it means is you're going to take out your lowest value and your highest value. And I know that this is you might be confused because there's 10 data points, and if I take away 2 points, that's 20%, right? 10 points, take away 2, we're taking away 20%. But really, when you say a 10% mean, you're taking 10% from the bottom, you're taking 10% from the top. So that's what that means, okay? So, 10 data points. We're looking for a 10% trim mean. So we found out that 1 data point represents 10%. So get rid of the 6.8. Get rid of the 9.0. Good? And now you do a normal mean with the remaining points. And you see there were 10, but we've taken the lowest and the top off, so now there's only 8. So now you do a normal mean, add them up, divided by the number, and you get a number of 8.3. Which, by looking at the numbers, if we get rid of this 6.8, if you're looking at the numbers there, a mean of 8.3 looks good. It looks good in there, okay? So that's what we call a trim mean. I'm only going to go for a 10% trim mean as far as I know. But that's what we're looking for there. So the 4 steps, not too bad. And look at that, we're already halfway through. Told you, it's not too bad. Now this one here, the weighted mean, this one here is true and dear to your heart because in your Blackboard grades, I don't normally start a weighted mean column in my Blackboard classes until probably about week 8. Okay, and this is where you take a test that's worth 20%, a quiz that's worth 5%, a lab that's worth 3%, an assignment that's worth 8%, and now you can mash them all together, which is what you want. Okay. The weighted mean is also known as a weighted average. It is similar to the simple mean, but instead of each term contributing an equal weight, okay, in the average calculation, now each of the term may contribute a different weight. Now, how do we calculate this different weight? And you'll see here you have your X bar, there's your mean, okay, and maybe it'd be easier here. Get rid of the English here. And what we have here is the sum, which you'll remember, of the weight times the data divided by the sum of all the weights. Now, mashed potatoes is probably going, what's he on about? It's all right. It's all right. We'll get there. Now, you look at this example right here. This store sells dressers. All right? And in this store, they sell 3 kinds of dressers. They sell cheapies made of particle board for $100. They sell aspen dressers. Woohoo, they look very nice. That's my favorite. At $200 a piece. And then oak. All right. $300 a piece. Now, let's have a look here. What are we going to ask? Let's just say if I wanted to find the average, we could calculate the mean. What's the average price if I put all 3 of these together? Well, you got 100 plus 2 plus 3, all divided by 3 because there's 3 of them, right? And that gives us an average price and a mean price of $200. So right in there, the aspen is right in the middle. Perfect. But not really. Look at this one. On average, every 2 weeks, the store sells 6 particle board dressers at $100 a piece, 4 aspen dressers at $200 a piece, and 2 oak dressers at $300 a piece. Okay? So 6 of these are sold in a 2-week period, 4 of these are sold in a 2-week period, and 2 of these are sold in a 2-week period. Now, how do we calculate the weighted mean? Because we've got a couple things going on here. The particle board is $100, but we're selling 6 of them. The aspen, $200, but we sold 4 of them. And the oak is $300, but we sold 2. Well, you take all those numbers, and you'll see here that from what we calculated here, this wrong mean, okay, and basically all you're doing is you're throwing the parameters in here. So how many of the particle boards did you sell? 6 of them. How many aspens did you sell? 4 of them. How many oaks did you sell? Okay, 2 of them. Okay, and sorry, I needed to change that. That's much better. So what we have here now is And I've broken it up into 3 different ways for you guys to see it. However way you like it, the math works. I don't care how you do it as long as you get it. So and what we did was we got 100. This is the particle board. Sorry guys, I'm gonna have to. My wife is gone. I'm gonna have to pause it for a second. I'm really sorry. Kids at home. Give me 2 seconds, guys. Hi guys. Apologies. It's just one of those things. Let's get on to it, shall we? Now, what we do here, and there's 3 different ways of doing it. This kind of way is kind of the same as this one here, but I've broken it up, and the math works. You've sold 6 of these at $100. Well, you've got 600 right here. You've sold 4 of these at 200. Well, you got 4 of them here, and you sold 2 of these at 300, and there you go. And you'll see there that our average is $167. And if you compare, remember that mean there we did there before, if you compare it to this one here, it's been dragged down a little bit. Why has it been dragged down? Well, I sold 6 of these. Okay, I only sold 2 of these. So it's not going to really be dragged up. It is going to be dragged down because the most dressers that we sold there were the cheapies. Okay, so I have a couple more examples. This is just another way of writing the mean here. So the weighted mean is your weight times your value plus your weight times your value plus your weight times your value, which is what we did right here. Okay, your weight times your value plus your weight times your value. So that's what we're looking for there. Okay, here's an example you guys can try. You don't have to try it right now. I'll walk you right through it. The final average. I like this question, by the way. I like it. The final average in a subject is determined by 3 tests and a final exam. So there's 4 bananas here. 3 tests, 1 exam. Each test is worth 15%. So there's 3 tests. There's 3 tests at 15%. So that's 45%. 15, 30, 45. And the final exam is worth 55%. So 55 and 45 is 100. So okay, our numbers are all add up. Everything's good. A student receives 65%, 75%, and 80% on the tests and 90% on the final exam. Calculate the student's final mark for the course. And there's your answer, 82.5%. But how did I get it? Same question up here. There's your formula. Okay, so 15% times 0.65. Okay, now we got to change these guys here to a percentage. One of the things, I have a math review that I'll show you guys there. Being able to change percentage to decimal is mucho bueno, importante. You got to be able to do that in order to do these. Okay, so if you have any issues with those, make sure you contact me and we'll set up a WebEx and we'll take 2 minutes and we'll sort you right out. Okay, so 15 times 65% plus 15 times 75% plus 15 times 80% plus 55 times 90%. Okay, 15, 15, 15, 100, all on the bottom. Okay, so you get 82.5 out of 100, which is 82.5%. That's how we calculate your final marks there for the end of term. Okay, that's a good one. Try a couple of these. Oh, and by the way, I don't know, the questions there that I give you guys at the during after we do a lecture, I give you guys questions and answers. And I don't know, I hopefully there you guys all have the books. If you don't have the books, well then the answers I'm giving you there, there's no questions here, it's just answers, right? Well, what I've done there, and I don't know if I'll get canned or not, but I've given you guys the questions here. These are the questions there in the back of 2.2. And they're all here. See, they go all the way to 16, and then you guys have all got the answers. Okay, and you see here the answers, and they go to 16. So, and it's everything there that we're doing there this week. So please try these out, okay, if you're having any issues. And I'm gonna, where are we here? Yeah, we just finished here. Okay, so there's your, that's for your weighted mean. Not too bad, I think, okay? So we've just covered, we went over simple mean again. We just did a 10% trimmed, and we did the weighted mean. Now we're on to these two here, and then we're done for the day, okay? The geometric mean allows for the calculation of the average rate of growth for a period of time. Now, why this is different is, I don't know if you guys have heard of the old riddle, would you rather have $1 million now, or would you like a penny doubled every day for a month? And of course, hey man, I'll take the million now, I don't really care, I'm out of here, right? But if you take the penny doubled every day, so day 1 is 1 penny, day 2 is 2 penny, day 3 is 4 penny, day 4 is 8, 16, 32, 64, 128, 256, 512, and now within, I think, 8 days, you're already up to $10. And it doubles to 20, 40, 60, 80, 100, and then I think it ends up you getting probably 3 or 4 million. You can calculate it out and let me know. So it's actually better to take the penny a day. But what geometric growth means is it starts off kind of slowly and then goes and then it's gonzo. It just explodes, because geometric growth is just another word for multiplication. And when you can grow things very quickly through multiplication. And we use this practice of geometric growth in, we've got bacterial cultures, we've got interest rates there when you're dealing with making money. You put $100 in the bank at 10%, you know what I mean? How much money you're going to have after 3 years. All right, we're going to get into that. It's not so bad. It's not so bad. But a little bit of math review. Normally, if you guys were in class with me, I would, and I do this there for my chemistry class too, because everyone's scientific calculator is different. And if you don't have one, you should have one there, especially for your physics there. Going on, what are you, week 6 in physics? So right now you're probably into universal gravity and these kinds of things. So make sure you have a scientific calculator. But you have a look here. If you see a number to the power 1/5, so you have what we have here is a fractional exponent. What that means is it's the 5th root of that number. So the 5 goes out front here, and we get a square root bracket. Now, more importantly, though, I want you guys to take a couple seconds here and see if you can get this number. So here I have 16,384, all to the power of 1/7. And if y'all are watching this video for, recorded and all that, then pause the video and try it. Okay, because every calculator is different, and this is where I would take 10, 15 minutes and walk around to all your desks and go through all your calculators, because don't let the calculator scare you. It's just a workhorse. It tells you what you input, and every calculator needs to be input differently. Okay? And so what we're looking at there, okay, is if you can get the number 4, and the button there that I found worked for this very well, is look for this button, X root, on your calculator. And how I input this into my calculator, like if I wanted to do this calculation right here, I would hit 7 and then this button, which I have to use a second function. Now you gotta, you know what I mean, however you get it, okay? So 7 and then this button, and then I input this number, and if you get the answer 4, then you're good to go. If you're not getting the answer and it's irritating you, email me. We'll set up a WebEx. We'll get it all going, okay? Because we'll have to do this. We're using fractional exponents here. And fractional exponents just means that they're just a square root, okay? Percentages and interest. We're going to talk about this there in a bit. But what I want you to remember is that 100% can equal 1. And you're probably thinking, what? Look at this one. 145% can equal 1.5. You see what I'm talking about here? 67% can mean 0.67. So you've got to be able to flip in between percentage and the decimal. Okay? Got to be able to do that. Any issues? Let me know. And you'll see here, calculating 17% interest on $100 for 3 years. How do we do that? So how much money am I going to make in 3 years? Okay, so I put in $100 at 17% interest. Whew, take that and run any day, because that's pretty good. And you see what we do here. There's your $100, okay? And this is equal to 100% plus 17%. So basically, that's 117% for 3 years. That's how we break this down. And this is how we calculate simple interest. Okay? So $100 times the percentage. And this is 117 or a 1.17. So our number is going to be higher than 100. And you'll see here, and we got it for 3 years. So, and what I've done is I've just broken this down into, there's your initial 100. And this is the interest for year 1. This is the interest for year 2. And this is the interest there for year 3. So, and here we go. 100 times this is equal to 100. I just added them all up. 1.7, and I think you get a number like $167. So over 3 years at this interest rate, you've made $67. Okay? So that's how we calculate this interest. We're going to expand upon that, but I just wanted you guys to realize that being able to flip in between decimals and percentage, you got to be able to do it. Okay? So let's have a look here. This is kind of a confusing formula, but what we're talking about here is this geometric mean, the rate of growth, the average rate of growth. That's what this means in here. And there's a couple of things going on here. See, you've got your fractional exponent. The n represents the total number of terms in the data point. But let's just go through this here, and we'll show you guys how to do this. Okay? And what we're dealing with here, the geometric mean, a geometric average, is, and there's two ways to write it. You could, all of your data points, okay, all to a fraction 1 over the number of data points, okay? Or as we've said there before, when you have a fractional exponent, this number here can go out front, and we've got a square root out. Either way works. And even you can plug this way into your formula. You would multiply everything here, and then you would use your y to the x button. And then with brackets, you could even use a fractional exponent. But just be careful when you get into heavy duty stuff with brackets and multiplying and all that. It's more, the chances of making a mistake are less likely if you break it down into little pieces and don't plug the entire whole thing into your calculator and hope and pray, hit equal, it's going to give you a right answer. Odds it won't. Okay, so this is why I want you guys to practice this. And practice using your calculator doing this. Okay. And here we've just a silly nonsensical. Okay. Doesn't make any sense, but I just want you guys to try this with your calculator. So here I've got 5 numbers: 4, 8, 9, 12, and 15. I want you to tell me the geometric growth, the average growth rate of these numbers. Now, it doesn't really, the ramifications of it, I'm just looking for you guys just to try the math and to get this answer. So if you're watching this video, you can pause it, try and get this answer in your out of your calculator. Okay, and if you can't, shoot me an email, we'll meet up, we'll clear it all up. Now, you got 4 times 8 times 9 times 12 times 15. You notice they're all multiplying. Okay, it's all multiplying. And because there's 5 terms, over 1 to the 5th. Okay, so you multiply them all out. Okay, do your 5th root. You get an answer of 8.76865, which we just round up 8.77. Try that out. Now, the average rate of growth for these numbers is 8.77. Doesn't really mean a whole hill of beans right now. There's no, it's nonsensical right now. Okay, I just wanted to show you guys. And I want you guys to practice inputting it into your calculator. That is it. Now we'll get into some meaning. Here we go. So Sam, Samantha, somebody invested $100 for 4 years. If the growth rate for each year was 10, 14, 17, and 18%, what was the average annual growth rate over the 4 years? Now, you might be inclined, be careful, when you see a percentage question, ding, 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 might be a little different, okay? And you might be inclined just to add them all up and divide by 4. 10, 14, 17, I'll just move this out of the way, and we get 14.75, okay? No, it's not. These growth rates are multiplication. And I'll show you why you can't really do it. Same question. What I've done here is I've kind of broken it down. So the end of the first year, okay, so there's your $100. Sam put in $100 at 10%. So at the end of the first year, she made $10, right? 10% of 100 is $10. So at the end of the first year, she had $110. At the end of the second year, okay, see that's there from the first year. And this right here is for year 2. So it's 14% interest on $110. You see how this thing is kind of starting to inflate? All right. So the first year Sam made $10, and you'll see there the second year she made $15.40. Third year, so there's first and second year. So the third year now, it's 17% interest on $125.40. Now it's getting up there. And you'll see here that for year 3, she made like $21. So made $10, $15, $21, and then there's the first 3 years, and here's year 4. So now they're making 18% on $146 And you see how this thing kind of geometrically goes. And if you get into the 5th year and 6th year, that's where things start to really take off. Okay? So, how do we calculate this? Well, it's a little different, and I've broken it down for you. And again, being the tests what they are, you don't have to memorize it. You just got to have it right beside you, right, during a test. So, how this works is, going back to our original math slide, which was right here, right? $100 times 1 plus the percentage times the number of years, right? Okay. And here we are right here. So here's your initial investment. Sam put in $100. And then we've got our 1 plus our growth rate, okay, which is going to change because year 1 is 10%, year 2 is what, 14, and then 17, and then 18. And how many years? 4. So, where are we going now? What does this mean? There's your 100. We're just expanding it. We're just plugging numbers in, and we're going to play. Plug and play. So, 100, 1 plus g to the 4. Well, expanded. There's your hun. So 1 plus G1, 1 plus G2. I'm oversimplifying this there for you guys here, just to show you guys. And then 1 plus G3, and then 1 plus G4, which means there's your 100 again. 1 plus 10%, 1 plus 14, 17, and 18. So then, okay, and we just added these guys together, 1 plus 0.1. So we got 1.10, 1.14. You see what we've done there. But dividing both sides by 100, okay, because we have 100 here on this side. We have 100 here on this side because that's just the nature of the formula, okay? So we just cancel it from both sides, okay? So that 100's gone. And then we get all the numbers. We multiply them all up, okay? And then we take the 4th root of this. So the 4th root of this will just be 1 plus g. That'll go away because exponents and roots are opposite. And I have to do, since I took the 4th root on this side, I got to take the 4th root on this side. Okay? And we get this number here, 1.147073. This number 1 over here comes on this side because we got to solve for g. Ultimately, the whole thing that we're solving for is this one right here, okay? And you'll get a number there of 14.71%, okay? That's what we're looking for there. Try these out. I've kind of oversimplified it, and in doing so, I might have made it more complicated. You know what I mean? All I can do is try. So if it's not making a hill of beans of sense, let me know, and we'll get this all sorted out. But the questions there, the review questions there at the end of the for section 2.2 deals with this exact same banana, and the answers are all there and they're all broken down. So try a couple of these. Don't try them all right? But try a couple of these and away you go, okay? There's something called the harmonic mean, and there's 3 different ways to do it. And so in order to answer this question, you don't really need to do the harmonic mean, but I'll show it to you anyway. So you have a look at this one here. A runner runs an hour in a straight direction at a constant speed of 15 clicks an hour. Okay? So you think about it. A runner ran for an hour at 15 kilometers an hour. How many meters did they run? How many kilometers? Well, if they ran for an hour at 15 kilometers an hour, they ran for 15 kilometers. Okay? So they're 15 kilometers out there somewhere after an hour. And then they turn around and walk home at a constant, so they're walking 15 kilometers at a speed of 5 kilometers an hour. 15 kilometers, 5 kilometers an hour, takes them 3 hours. So it's 1 hour there, 3 hours back. Okay? You guys have done your physics. You guys know speed is equal to distance over time. Okay? what is the runner's average rate of speed? Well, you can't really just add them up. Maybe you want to add them up. 15 divided by, you might want to go 15 plus 5 is 20 divided by 2 is 10 kilometers an hour. That's the average. Well, it ain't. Okay? Because you've got the runner traveling 1 hour at 15 kilometers an hour, and then back again 3 hours at 5. It's apples and oranges, right? So you can't really do this. But logically, if you can deduce this, and if you can see this, then this question is cake. But I've got 3 different methods. Hopefully one will stick and it's not too bad. So whenever you see one of these, like a running question or these kinds of things here, you're going to have to use this kind of logic here. So if the runner runs for an hour at 15 kilometers an hour, he or she has run a total of 15 kilometers, like I said, right? Running for an hour, 15 kilometers an hour. Well, for 1 hour, 15 kilometers an hour, by the very definition of kilometers per hour, I've now run 15 kilometers. So to get back home has to be another 15 kilometers. Okay? So that's 15 and 15 is 30 kilometers is my total trip. Took me 1 hour to get there, 3 hours to get back. So that's 4 hours total. So easy peasy, 30 divided by 4 gives me 7.5 kilometers per hour. And that is the correct answer. To me, this seems the most logical, but there's another way we could do this. In this scenario here, the runner ran at 15 kilometers for 1 hour, but walked 5 kilometers for 3 hours. Well, what if we just use the weighted mean? 15 times 1 plus 5 times 3. 15 times 1 is 15, plus 5 times 3 is 15, so 30 divided by your total time, which is 4. You still get the same answer, 7.5 kilometers per hour. So you could actually use the weighted mean to solve this question, or you can use what's called the harmonic mean. And normally in a testing situation, if I wanted to see this, I would give you, and I would ask to see your results, and I would go, I would ask to see this. But you'll see here that this is your harmonic mean, okay? And quite frankly, I don't care how you get this answer, as long as you get 7.5, okay? That's what we're looking for. And the harmonic mean, h is equal to n divided by the sum of the reciprocal of the numbers. Reciprocal just means that a number has been flipped. So the reciprocal of the number 2 is 1 over 2, 1/2. The reciprocal means I just put a 1 over top of the number and turn it into a fraction. So the reciprocal of 3 is 1/3. The reciprocal of 10 is 1/10. The reciprocal of 1/8 is 8. It's the flip, right? So that's all we're doing here, is you're going to have to flip these numbers around. And same question, 15 kilometers in an hour, 3 hours to get home, 5 kilometers an hour. And what you do is, there's your number. It's now on top. So you got 2 numbers there to deal with. And you got 1 over 15 and 1 over 5. Okay, that's these guys here. Okay, is equal to 2 over 4 over 15. And you just solve this up, and it comes up with the right answer as well. So you've got 3 ways to solve this question. Doesn't matter which way you choose it at this point in time. But the harmonic mean is involved in these ones here, okay? Review questions. Y'all can try these out. Determine the best type of mean to use and solve for the true average. So the following data indicates the money spent in dollars on books during 2015 by 10 college students. So just have a look at your numbers. And this is going to force you to look at your data. You can't walk into a question blind anymore. You are responsible for answering this question as best as you see fit. And so you have a look here. I got $900, $750, $600, $945, $85 is all this student spent on books. Yeah. 648, 792, 855, 9. Hey man, all these numbers are in the high hundreds, except for this one here. And how many do I have? I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You know what? Let's just do a 10% trim mean and get out of here, shall we? So you put them all into order. There's 10 numbers. And in this case here, 10 numbers, 10% of 10 is one number. So we're going to knock off the lowest and the highest, which in this case is 982, and we get a trim mean average of 776.50. Okay. You have a look here on a trip. Sarah drives 80 kilometers for the first half of the journey and 100 kilometers for the second half of the journey. What is her average speed? Using the harmonic mean. But you don't really have to use the harmonic mean. You can use the common sense method, or you can even use the weighted mean. So however y'all want to do it, as long as it gets done. Okay. And then we've got our questions here. Okay. And you guys have the answers. You guys have your case study. You guys have a great reading week and enjoy yourselves. Do take some time off. And you guys are now 3/4 the way through pre-health. You guys are on the last leg. And I hope you guys are doing very well. Are there any questions? How we doing? Thanks. Yeah, the case study is due. I don't know. I think it's due it's Thursday at midnight or something like that. I'm not too worried. Just get it into me Thursday sometime, and you guys will be fine. I don't think it's too bad. July the 8th. Yeah, whatever. The 2 Thursdays from now. Sounds about right. So other than that, I think you guys are doing good. Okay, good, Nicole. That makes me happy. So if you guys have any questions other than that, get out of here and start your reading week a day early. Bye, guys. I'll post this there to YouTube now. Take it easy and be well. Thanks, Brandy. Appreciate it. I'm going to stop recording. And that is it, eh?